Welcome to BEdit. In case you do not know what BEdit is, it is a binary file editor, and today I will show how to structure it to get a better understanding of what is inside a TTF file. A TTF file is a TrueType font, which is what you see here. It is the inconsolata I will be going through. To tell BEdit what the file contains, I will be needing a little bit of help, and in particular I will be needing some documentation of what a TTF file consists of. I have found two reference manuals. One is the Apple, which I believe is the author of the file format itself, and the other one is Microsoft through the MSDN documentation. And I personally prefer the Microsoft one, not only because it has a dark theme, but also because it's a little bit easier to read. So let's get straight onto it. The first thing I would like to know of this file format, and I can already see that it is a big endian, and BEdit by default uses little endian. So let's change that immediately. Like so. So what is the beginning of a TTF file? If we scroll down, I have already read this. I suggest having a quick scroll through it. The beginning of the file starts with the table directory. So let's model this to BEdit so it can start laying out data for us. And we can see they're using 32 and 16-bit unsigned data. So it's pretty easy to add to BEdit. .32 is 4 bytes. And 16 is 2 bytes. We could also do a type def and simply specify the type alias here, but I don't see much value in it myself. Like so. You can create many types in BEdit, and BEdit needs to know which type it is that you want to lay out. And we know that the file starts with the table directory, so we can simply say layout table directory. Let's see what we get. First, to make sure that the source code is loaded, we can see it appears to be. And it is auto reload, so whenever I change anything in the text editor, it should appear in the BEdit. And it appears we have 17 tables here, but the version should be either 00. Yes. So it doesn't bring much value to show the version as a decimal value. To change that, you can either specify it as hex, which will show it as a hex value in whatever byte order you have specified. If you want to see it in the actual byte order, that is the lowest byte first, you use raw. This looks to be correct. If we go back to the documentation, we can see that there is a num tables amount of table records. So what is a table record? If we scroll down, we see table records defined as a tag, a checksum, an offset from the beginning of the font file, and a length. And we can add that pretty trivially. Of course, what are tags? We'll have to check that later. Whatever a tag is, I'm not sure. And a 4-byte unsigned integer. And I personally prefer to have offset displayed as hexadecimal values. It's a personal preference, you can skip this if you like. And if we go back to BEdit, we should not have question marks there. Let's see if that works. And of course we also need to add the table records. And you can add more layouts after the table record, but the table directory showed it as an array, so I say let's do the same. Like so. Now we start getting some table records. If this is correct or not, that I'm not sure about. Let's check what a tag is. A tag is 4 bytes, unsigned bytes. And it is also a Unicode character. So it's basically just a string. Let's check that by simply writing string. Yes. This looks quite okay. One note that BEdit does not have any alignment for the members, and the tables must be aligned to a 4-byte boundary. But that doesn't seem to be an issue here, and if we double check, the alignment they're talking about is a table record here. That is 4 bytes, that is 4 bytes, that is 4 bytes, and this is 4, 4, 4, 4. So the record will always be aligned to a 4-byte boundary. Currently we have the beginning of the file up to 118, and if we have a bigger look, it's a very small part of the file. So let's check what other data these tables contain. So if we go through these in order, the first one is gdef. And gdef is the glyph definition table. You can find this by expanding the tables and go gdef. So this table provides various glyph properties. Alright, well, what are these properties? The table begins with a header that starts with a version number. As we can see here, there appears to be 3 defined versions, 1.0, 1.2, and 1.3. So if we just start modeling this in BEdit. It's pretty straightforward. I believe you already know how to do this. The type would look something like this. Of course, this is for the 1.0 version. The 1.2 version seems to add one member, which is the mark glyph sets depth offset. And the 1.3 version seems to add another member. But let's first see what version we have. And this header is expected to be at the offset address if the table tag is gdef. So let's first check that. Like so. And here we can see that some more content got added. Now I would prefer to view this more by member instead of by address. The by address view is quite fine if you are interested in what the members are by the address. But now we are more interested in what the members are by the hierarchy. And for that there is the member hierarchy view. So if we see the first table record, we see that it is gdef, and well, this looks wrong. Of course, by saying gdef header gdef, we are telling BEdit that the data is coming immediately after this length member, but that is not true. gdef header is at offset. To tell that to BEdit, we say at offset. But this is not enough. If you say at offset, it will continue incrementing the length of this record until the gdef header has completed. So in other words, the table record will be this size plus the offset plus the size of this length, and that is not correct, and that will cause subsequent tables to be incorrect. So this is what you can call an external member. This means there is a member I would like to display at this address, but it shouldn't be counted to the size of this table. Now we can see this looks much more sane. So the version is 1.2, and what we have here is the version 1.0. Now, as the 1.2 only adds one member, what we can simply do is, well, first let's assert that the major version is 1. Otherwise this breaks down. Alright. If the minor version, let's first check. So this member, which is in the 1.3 version, is also in the 1.2 version. So they just added more stuff on the end. So we can simply do, if the minor version is greater or equal to 2, then let's add the other member. And although this file doesn't have it. We can be a little bit future-proof by also adding the one free version. Oh, that shouldn't be an else if, should it? Should just be an if. Oh, that's a 4 byte. Is this also 4? No, it's a 2 bytes. Okay. And as said before, I prefer to see the offsets as hexadecimal. So we could now go on and see what these other tables are, and I will not go through them all, it's not gonna be that long video, but I first would like to know what the class definition is, or a glyph class definition. So let's have a quick look. It comes in one of two formats. There's the first format, which is quite simple, and a second format which doesn't seem that complicated either. Alright, let's put it in. And I will assert that it is either 1 or 2 at this point. Unlike the gdef header, this struct is not just added members at the end, but these are somewhat different. So except for the first member, which tells which type it is, I'll just make two different versions of it. You can put these in two different types as well and just have it like that, but it's up to you. Now this class, I'm not sure exactly what is. If we go quickly back here, I suppose it is one of these. We'll see it soon how it's used in the file. So, assuming that the glyph class def offset is not 0, you could also skip this, just write it like this. Then we will have external member of, yes, this is from the beginning of the header. So this would be the beginning of the header, and we would need the current address of this, and we can do that pretty easily. Like so. And here we have it. So there are 35 ranges, and it is using the second format. So it is going through this branch. and most of them appear to have class 1, if not all of them. No, there are some others as well. So I would be curious, it was 1 and 3. So it would appear that these values here basically tell the meaning of the class. So what we can do is use an enum to make this a little bit easier to read. And this would be, well, it even says enumeration list. It's called glyph class type, maybe category. Well, the glyph is pretty apparent. So we got base, ligature, mark, and component. Alright. So this is not an unassigned int, it is a glyph class type. So let's see. Ligature. So what was what here? Let's refresh our memory. A ligature glyph is okay, yeah. So ligature should not be appearing that often, and we can see that the enum starts with 1, but BEdit enum starts with 0. So we should expect to see most base glyphs. Yes, and that is what we see. The other ones are mark. Alright, I think that is the glyph classes. And we could continue going through all the tables that we have in this file, and we can even go through all the tables that Microsoft and Apple has documented. But I think you can, if you're interested, you can continue on that yourself. To get a little bit of perspective on how much of the file we have recorded, it's not that much. It's a fairly large file, and we are just scratching the surface. Let's see what the highest address is. Highest address is 1FE, and yeah, you can see we can continue on this for quite a while. But if you are writing a font reader or a writer, you might be interested in that there are some tables that are required to exist, at least on the Windows versions. And here you can see them. And that pretty much concludes what I had to show today. If you are interested in trying out BEdit yourself, you can get it on itch.io. And keep in mind that BEdit is still in early development, and if you would like to try before buy, there is a command line version. That you can download from the Handmade network, or if you want to build it from source, for example if you are on Linux, you can download and build the source of the command line version yourself from Bitbucket. For full documentation, and if you get any bugs, head over to GitHub, where that is exactly where you're supposed to be. Links are also in the description. Bye for now.